Good morning, everyone. Mr. Cutterback here. Happy Monday at almost 9 o'clock in the morning. Hopefully you're doing all right. All right, 7.6, common logarithms. All right, we got the log lady here. Where is she? Right there. She's got the log in hand. Looks like she's got the little wedding ring. I don't really remember that in Twin Peaks. I don't remember her mentioning being married. I'll have to revisit that. It's Twin Peaks. What a great show. Check it out. Okay, let's see here. So today we're talking about common logarithms and something called the change of base formula. All right, let's check it out. A common logarithm is, in this case, a base 10 logarithm. But the deal is, in order just to save time by not writing the actual base, it's just implied that if you have log, the word log with no base written after it, and then you've got your argument x, that's the same as log base 10 of x. So if there's no base written following the word log, base 10 is implied. So here we go. So use a calculator to evaluate log 6 to the nearest 10,000th. So remember that log 6 is the same as log base 10 of 6, so I could write that little 10 in if I wanted. And but the nice thing is when you drop this into your calculator and you do your little diamond 7 thing, and then you get log with your open parentheses, all you need to do is drop in your argument and close parentheses and hit enter, and that is let's see, diamond 7 6 parentheses, and what did I do there? Diamond 7 6 parentheses 0.778151, 0.778151, but this says round to the nearest 10,000th, and so we let's see, that would be the fourth decimal spot, so 7781, but this 5 is telling us to round up, so that equals 0.7782. Okay, there we go. We just evaluated a common logarithm. All right. And then for this next one, evaluate log of 0.35. Just drop that into your calculator, and you will get negative 0.4559. 0.4559. All right. There you go. Common log. Next. Okay, property of equality for logarithmic functions. This is kind of fun. This is just how you can see really what you can do with, how to use the logarithmic function. Okay, so in the same way that if, in the example, if you had like x squared equals 64 and you wanted to unlock that x from the exponent of 2, you would take the square root of each side. Okay, so whatever you do to one side of the equation, you have to do to the other side, and of course that would give you x equals positive or negative 8. All right. Well, you can also use that same kind of approach with logarithms. So here we have 5 to the x equals 62. So I'm going to rewrite that. 5 to the x equals 62. And of course, yeah, we can write this in logarithmic notation and call it log base 5 of 62 and drop it into our calculator. But this is more of an exercise in how to use, what we're talking about right now is more of an exercise in how to use logarithms. And so what I can do here is I can apply a logarithm of same base to each side. And so I'm going to apply a common log to each side. Remember, that's log base 10. And what that does is it drags our little x over here out to the front of the expression. And so then this becomes x times log of 5, which equals log of 62, and now I'm solving for x, and so you guessed it, I am going to divide each side by log of 5. Okay, and then I have x equals log of 62 divided by log of 5, and then you drop that into your calculator, and what do you get here? Log of 62 divided by log of 5, where are you? Okay, I think it is about 2.5643. 2.5643. And of course, you would get that same exact thing if you just converted this to logarithmic notation right out of the gate. Log base 5 is 62. You would get the same value. But this is just more of how you can apply logarithms to different expressions, or equations rather. You can just kind of apply the same log to each side and see what happens. Alright, let's look at this next example. What do we have here? Okay, so the solution to the equation 3 to the x equals 17. Well, we can do our little log thing here. So we got 3 to the x equals 17, and I will just apply the common log to each side. Okay, and let's see here. Then we get x times log of 3 equals log of 17, and solving for x, you get x equals, let's see, I think I already did this one. Yes, 2.5789. 2.5789. Yeah. That is the property of equality for logarithmic functions. You're just applying a logarithm to each side of the equation. But you know what's kind of fun about it? It doesn't just have to be log base 10. It could be log base 20. It could be log base 7. It could be log base e. It could be log base pi. It doesn't matter as long as you apply the same log, same base to each side. Okay, what else do we have here? Change of base formula. Another great little formula here. Let's take a look at the math speak. For all positive numbers a, b, and n, where a does not equal 1 and b does not equal 1, log base a of n is the same as log base b of n over log base b of a. Okay, what does that mean? Well, notice that we have an a in the base and an n is the argument. And now we have an n over here as an argument and an a as an argument. What's happening here is this change of base is basically saying you can take log base anything of the argument divided by log base that same anything of this base, a, and turn it into a little quotient here, okay? So in this example, log base 3 of 11 is the same as log of 11 divided by log of 3. Notice how I didn't say 10, because I don't need to. I can just say log. I could have said log base 10, but you know, we all want to save time, so I just shaved at least 1.5 seconds off of that computation by not saying the word 10. Okay, so let's take a look at this. Express log base 5 of 140 in terms of common logarithms, then round to the nearest 10,000th. Okay? Log base 5 of 140 is the same thing as log of 140 over log of, oh my goodness, log of 5. So that's supposed to be a 140. Okay, remember this is a common log. Let's log base 10. Drop it in your calculator. And let's see here. What is log base 40? Where are you? Diamond 7, 1. Sorry, log base, or sorry, log of 140. All right. That equals 2.1461. 2.1461 over log of 5. Diamond 7, 5. Enter. 0.69. Ooh, 0.699. 0.699. And then that equals, let's see here. enter, divided by, enter, enter 3.0704. 3.0704. Okay, so what we did here is we expressed log base 5 of 140 in terms of common logarithms. Okay, we take log of 140 divided by log of 5, and you just go to town here. All right. You know what? I'm not going to do that next example. I'm just going to show you how to set it up. Oh my goodness, come on now. I'm almost there. Okay, there it is. All right, and so once again, we can write this as log of 16 over log of 5, and then solve. So you'll see a question like this on your test, and the big takeaway here is you have to know what it means. You have to know what the language means here when it says what is blah 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 expressed in terms of common logarithms. What that means is you're converting it to this quotient of log base 10 of the argument divided by log base 10 of the original base. All right? All right, there's your assignment. Have fun with it, okay? I mean that. All right, we'll see you on, we'll see you tomorrow. We'll see you Tuesday. Okay, bye.